Hi, I will solve problem 5.14 from the book Design and Analysis of Experiments by Montgomery. Here we have the response variable, the thrust force. Our parameters are drilling speed and feed rate. There are two levels of the drilling speed and 4 levels for the feed rate. So the low level and high level of drill speed are 125 and 200 respectively, while these are the 4 different levels of feed rate starting from 0.015 till 0.06. Further, at each combination they have performed 2 replications. For example, at the combination of 200 and 0.015, these are the 2 replications, 2.83 and 2.86. To make this design, click on Stat, then DOE, then Factorial, create a factorial design. We have different levels for each of the factor, so we will select General Full Factorial Design. We have 2 factors, then we click on the design, and in the design we have to give the name of the factor, one of them drill speed and feed rate. You can specify the levels. There is an arrow button, so you can increase or decrease the number of levels after entering the information. So we have 2 replicates, so enter 2. I told you about the replications. Now after entering the information of the design, it's time to enter the information for the factor. So drill speed numeric, 2 levels. The first level is 125, the second level is 200. Now again feed rate, the type is numeric. You can also select the text, but for those cases where we have medium, high, or you can say small, medium and high, when there is a text available. But in this case we have numerical digits available, so 0.015. let me check this other one, 0.03, 0.045. so let's go to this 0.03, 0.045, 0.06. so these are the 4 levels. Click OK and then go to the options. Please uncheck this randomized run, click OK, click on the result tab, nothing to do in this, click OK and then OK. So we will get our design. Click on this data only tab. So this was our basically the whole design. As I have unchecked the randomized run, so we have the randomized run order in the ascending order. Now right here the response variable name thrust force, and after that I have to enter the values. So how we can enter the values? For example, for 125 and 0.015 we have the value of 2.70. let me enter it. Then for 125 and 0.03, so we have our second value, that is equal to 2.45. the third value for 125, 0.05. so let me tell you a shortcut that you will have to enter the data for the entire row. For example, here we will get directly 2.60 and the next value will be 2.75. Now you can see you will have the next 4 values for the drill speed 200, and these are the levels that are varying for the feed rate. So we will have to memorize the 4 values for this 200 row: 2.83, 2.85, 2.86 and 2.94. I entered the 4 values. After that again I will enter the second row for the drill speed 125. So these were the 4 values, 2.78 till 2.86. let me copy them all off. Now we are left with 200 and these 4 levels, so we will have to enter the last row. After the completion of the data, the steps are quite easy. Go to Stat, DOE, Factorial, Analyze Factorial Design, select your response variable by doing the single click and click the select button, or you can do the double click directly. Now go to the graph. In the graph, select 4 in 1. This is the first step because you will get the graph. By using the graph we will satisfy our assumption. We can check our assumptions. Now click on results. There is 2 options, simple table and expanded table. Click on the expanded tables, click OK. Then after these 2 steps, click OK and then click on this button, output only. So you will get the results only table. Now here first of all come downward and have a look on the tables. So double click on these 4 figures, you will get an expanded view. So you can see the data is ideally normally distributed. So again, this showing normally distributed, fitted values are seems somehow okay, and the versus order, there is no such dependency of the data is found. So our assumptions are found to be satisfied. So now we can see our analysis of variance table. Let me maximize it. So this analysis of variance table is telling us that the drill speed, feed rate, and this interaction term, drill speed into the feed rate, the p-value associated with all these main effect terms or two-factor interaction term are less than 0.05. Therefore, they are found to be statistically significant. Now, further, this model summary is telling us that the drill speed and feed rate and their interaction term is explaining 93.14% variation in the thrust force. It means that there are a lot of the factors that are affecting the thrust force. Out of all those factors, the 2 factors that we have taken into our study, they are explaining 93.14% increase or decrease, variation in the thrust force. Now the next step is to perform a regression analysis which help you to get a regression model. So my response variable is thrust force and my predictors are drill speed and feed rate. Select both of them and then click OK. You will get a regression equation. So this was my regression equation, and we will get some ANOVA table like previously. Further, here a problem has been occurred that our model has lack of fit value, p-value less than 0.05. It means that our model is not fitting the data in a good way, so we can ignore the regression analysis results. Now we will have to make main effect plot and interaction effect plot. For doing so, click on stat, ANOVA, then main effect plot, select the name of the response variable. So my response variable is thrust force. After that, click on drill speed and feed rate data over factors, then click OK. So you will get these 2 graphs. Okay, so now these 2 graphs are explaining that with the increase in the drill speed from 125 to 200, there is an increase in the thrust force. Whereas if we see the graph of feed rate, so we can see at the feed rate of 0.03, we have the least thrust force, whereas we have the maximum thrust force at the level of 0.06. Now, if we are interested in minimizing the thrust force, so we will have to select drill speed of 125 along with 0.0. After the main effect plot, now we will have to make interaction plot. Click on stat, then ANOVA, interaction plots, then click on our response variable is thrust force, factor are feed rate and drill speed. Click OK and we will get such a graph. So you can see in this graph there is a very obvious intersection, or you can say the 2 lines are overlapping each other at some point. So whenever the lines are overlapping each other, there is an intersection of the lines, so we got our interaction as significant. So that was all about the video. Thanks for watching it. Bye.